That is the nature of modern food manufacturing. Invisible effort, visible quality. The mango that arrived at the factory gate a few hours ago has been washed, peeled, pulped, refined, pasteurized, filled, sealed, labeled, and packed, all with a precision and care that the consumer will never see but will always be able to taste. What makes a modern juice facility remarkable is not any single machine, it is the system. Every element interlocked and reinforcing one another, from raw material to finished palate. From a mango growing in an orchard to a bottle sitting on a shelf, the journey spans days, dozens of process steps, and the combined effort of engineers, food scientists, quality technicians, and logistics professionals working around the clock. This practice, known as finished goods hold and release, is a fundamental safeguard ensuring that no bottle leaves this facility without full confirmation that it meets every quality and safety standard. Finished product is held under quarantine until every test result has been confirmed. Only when all results pass does the quality manager formally release the lot for shipment. Microbial test results require 24 to 48 hours of incubation. Until all results are confirmed satisfactory, every pallet remains under quarantine status in the warehouse. A typical finished product test panel includes bricks, pH, titratable acidity, color measurement, viscosity, microbial analysis, and sensory evaluation, which remains irreplaceable even in the most automated laboratory. Behind every production line is a laboratory operating around the clock, responsible for incoming material testing, in-process checks, and finished product testing before any pallet is released. Treated water is UV sterilized before entering any part of the production system, ensuring every drop that contacts the product meets the highest standards of purity. The facility maintains its own on-site water treatment plant. Incoming water passes through multi-stage filtration, sand, activated carbon, and reverse osmosis membranes before it is used anywhere in production. In addition to CIP, all accessible surfaces in the production area are cleaned and sanitized during scheduled deep clean shifts, the frequency and depth defined in the facility's food safety management plan. Swab tests taken from clean surfaces after every CIP cycle confirm that residual microbial counts are within acceptable limits before production restarts. A typical CIP sequence moves through caustic solution, water rinse, acid solution, final rinse, and sanitizing rinse, each phase monitored automatically for temperature, concentration, and contact time. Clean in place, CIP, is the primary hygiene method used throughout the facility. Cleaning solutions are pumped directly through all production equipment while it remains fully installed. First in, first out dispatch rules ensure that the oldest stock is always the first to be shipped, maintaining product freshness across the entire inventory. The finished goods warehouse stores every completed pallet under controlled temperature conditions, organized by lot code and production date, managed by a warehouse system that tracks every single pallet's exact location. Automated guided vehicles transport completed pallets autonomously across the production floor, quietly navigating their programmed routes without any human direction. Once fully built, each pallet is wrapped in stretch film, binding all the cases into a single stable load capable of withstanding the vibration and movement of road transport. Each layer is placed with the same precision as the last, the pallet building steadily upward, case by case, in a perfectly organized load. Robotic palletizers stack entire layers of cases onto pallets in interlocking patterns calculated for maximum load stability, operating continuously without fatigue. Each case receives a shipping label and is immediately scanned by a barcode reader, registering it in the warehouse management system with full lot traceability. The case sealer applies adhesive tape across the folded top flaps in a single continuous pass, the case exiting fully sealed and ready for palletizing. Robotic arms place bottles or multi-packs into open cases with precise, repeatable movements, operating continuously and handling every group with the same controlled accuracy. Case erectors fold flat cardboard blanks into open boxes automatically, preparing the secondary packaging that will protect the product through the entire distribution journey. Emerging from the heat tunnel, each multi-pack is a compact, stable unit, easy to carry, easy to shelf, and ready for the next stage of packaging. Individual labeled bottles are grouped into multi-packs and encased in a sleeve of polyethylene film before heading into the shrink tunnel. Best before dates are applied by an inkjet coater that prints the date directly onto the bottle cap, completing the traceability information on every single unit. Each label carries the lot code, a unique alphanumeric identifier that allows the facility to trace exactly which batch of raw mangoes, on which production date, was used to make any given bottle. Sleeve labels are placed loosely over the bottle and pass through a heat tunnel, the film shrinking to conform perfectly to the contours of the container. For pressure-sensitive labels, registration sensors ensure every label is placed at exactly the correct height and orientation, every single time, at full line speed. A bottle without a label is just a container. The labeling machine applies labels at speeds synchronized with the rest of the production line, giving each bottle its complete identity. Trained quality assurance personnel conduct periodic manual inspections alongside the automated systems, because sensory evaluation remains an irreplaceable quality tool even in the most automated facility. For products in clear bottles, a vision camera checks the external appearance of the juice, looking for unusual color variation, visible foreign particles, or excessive foam, all assessed in milliseconds. A cap inspection system checks every bottle for a properly seated cap, sensors detecting missing caps, partial threads, or incorrect angles before any non-conforming bottle can proceed. Underfilled or overfilled bottles are automatically ejected from the line, diverted before they can proceed any further, without slowing production. Every bottle that exits the capping station passes through a fill-level inspector, using light transmission or X-ray technology to verify that the juice level falls within the allowed tolerance range. Each sealed bottle is briefly inverted to ensure the hot juice contacts the cap surface, completing the pasteurization of the entire sealed unit before cooling begins. In hot fill lines, bottles are filled at high temperature then immediately cooled in a water spray tunnel, the residual heat having pasteurized the interior of the bottle and cap simultaneously. The capping head applies the correct torque to tighten each cap to specification, monitored electronically to ensure every cap is neither too loose nor over-tightened. Immediately after filling, each bottle enters the capping station. A cap feeder orients loose caps automatically and places them precisely onto each bottleneck as it passes. The fill volume is controlled electronically, the nozzle cutting off at exactly the correct level every single time, ensuring every bottle is filled to the same precise standard. A large-scale rotary filler can fill anywhere from 20,000 to 60,000 bottles per hour, every component engineered for precision at that relentless speed. The filling line is the heart of the factory, the point where the processed juice and the prepared containers finally come together. Before any bottle reaches the filler, it passes through a rinser that inverts each bottle and flushes the interior with filtered air, removing any dust or debris in a single second. Bottles move immediately from the blow molder to the filling line via a sealed, controlled environment conveyor, minimizing any exposure to airborne contamination. When the mold opens, a perfectly formed clear bottle emerges, already the correct shape and size, and joins the stream moving toward the filling line. A stretch rod elongates the preform while high-pressure air inflates it to fill the mold cavity, the entire cycle from preform to finished bottle taking only a few seconds. The preforms are reheated in an infrared oven until the plastic becomes soft and pliable, ready to be formed into the final bottle shape. While the juice is being processed, on a parallel track, the packaging operation is being prepared. PET preforms, compact plastic pieces with a threaded neck, are the starting point for every bottle. The result is a smooth, stable product, resistant to separation during its shelf life, and maintaining that consistent, vivid golden-orange color from production all the way to the consumer. The homogenizer forces the juice through extremely small orifices under several hundred bar of pressure, breaking down pulp particles into uniformly smaller sizes and distributing them evenly throughout the liquid. From the deaerator, the juice moves to the homogenizer, a machine that will ensure the final product remains smooth, stable, and consistently colored throughout its shelf life. Under vacuum conditions, dissolved gases, including oxygen, are drawn out of the juice and extracted by a vacuum pump, measurably extending shelf life and preserving that vivid golden-orange color. After pasteurization, the juice enters the deaerator, a vessel operating under partial vacuum designed to remove dissolved oxygen that would otherwise degrade the product's color and vitamins over time. Immediately after pasteurization, the juice passes through a regenerative cooling section, the incoming cold juice absorbing heat from the outgoing pasteurized product, significantly reducing energy consumption. If the temperature drops below the minimum required value, even briefly, a flow diversion valve automatically sends the affected juice back to the beginning of the heating cycle. The juice is brought to a precisely controlled temperature, typically 90 to 95 degrees Celsius, and held there for a scientifically calculated duration to achieve the required reduction in microbial load. The juice flows through narrow tubes in close contact with a channel carrying hot steam, heat transferring from one to the other without the two fluids ever making contact. Once standardization is confirmed by laboratory sign-off, the vivid golden-orange juice base is pumped through closed stainless steel pipework into the pasteurization system. Every addition is logged and traceable. The goal is to ensure that every batch is indistinguishable in quality from the last, consistent, repeatable, and verified. If acidity needs fine-tuning, a food-grade acid, typically citric acid, which occurs naturally in many fruits, is added in precisely calculated quantities. Brix indicates the sugar content. pH indicates the acidity. These two values directly affect the taste, the shelf life, and the safety of the final product. At regular intervals, samples are drawn from the tank and taken to the laboratory, where the key measurements of Brix and pH are verified against target specifications. From the refiner, the pulp moves to a large holding tank where the standardization process takes place, balancing sugar content and acidity to meet precise product specifications. The pulp passes through a refiner, a finer screened machine that removes residual fiber and ensures the pulp has a consistently smooth texture before standardization. What emerges from the pulper is raw mango pulp, a thick, fragrant, golden-orange mass whose quality at this stage will define every bottle that follows. The pulper forces the mango flesh through a fine metal screen using rotating paddles, creating a smooth, thick puree while removing any fiber too coarse for the final product. The mango cheeks flow forward in a continuous stream toward the pulper, their vivid golden-orange flesh glistening with natural juice. The destoning machine holds each mango in a cradle, while high-speed blades make two parallel cuts along either side of the central stone, the cheeks separating cleanly away. The peeled mangoes, their flesh a vivid, deep amber orange, move steadily toward the destoning machine at the next station. Rotating cutting heads with curved blades follow the contour of the fruit and remove the skin in continuous strips, the blade geometry designed to preserve as much flesh as possible. Mangoes are fed into the peeling machine individually, positioned by guides that align them precisely before the blades make contact. The processing section houses a sequence of specialized machines, the peeler, the destoner, and the pulper, each designed to handle the mango's unique physical structure. Following the spray wash, the mangoes enter a final rinse station where clean potable water removes any residual sanitizer from the skin. The fruit is now clean, sanitized, and ready. High-pressure nozzles fire jets of treated water at the mangoes from every angle, the pressure calibrated to dislodge contaminants without damaging the fruit. Before any mango is cut or processed, it must be thoroughly cleaned. The washing process in a modern juice facility is multi-stage, beginning with large cold water tank baths. Rejected fruit is not wasted. It may be composted, converted to animal feed, or directed to a secondary processing stream. Nothing is discarded carelessly. Optical sorters capture thousands of images per minute, and a jet of compressed air automatically diverts any flagged fruit off the main belt, all in a fraction of a second. A mechanical pre-sorter uses a system of rollers and gaps to separate mangoes by size, ensuring the main processing line receive a consistent size range. Mangoes are unloaded using a combination of mechanical conveyors and careful manual handling. Mangoes bruise easily, and bruised fruit can introduce off flavors into the final juice. Only when a shipment passes both visual and laboratory checks is it formally accepted. The unloading process then begins. A reading within the acceptable range confirms the shipment is suitable for processing. If the Brix reading is too low, the entire batch may be rejected or held for further assessment. Samples are taken to the on-site laboratory, where the Brix level is measured using a refractometer, an instrument that determines sugar concentration by measuring how light bends through a drop of juice. A ripe mango suitable for juice production should have a deep golden yellow skin tone, a firm but slightly yielding texture, and a rich, sweet aroma. Quality inspectors use a statistical sampling method, examining fruit for ripeness, skin condition, color uniformity, and the absence of mold or physical damage. Every shipment carries full documentation: the farm of origin, the harvest date, the variety of mango, and the estimated sugar content, known in the industry as the Brix level. The journey begins long before anything is bottled. Large refrigerated trucks pull into the receiving dock in the early morning hours, each carrying several tons of freshly harvested mangoes. Every morning, before most people have poured their first glass of juice, a factory has already been running for hours, and this is the story of how millions of bottles of mango juice are made every single day.